Hey guys, this is the first video in my playlist about the Probe 1 contest. This whole playlist is kind of intended for SHS slash BMS students. I used to be on the SHS math team. I took the Probe 1 all 4 years, and on that contest I had varying degrees of success, but I've got some experience with it, so I'm going to be going over 5 problems at a time. Hopefully, you can watch this and work along. And without further ado, let's get into the problems. Okay, question 1. How many real roots does the equation x cubed plus 5x squared minus 7x plus 1 have? Okay, so if this were something like ax squared plus bx plus c equals 0, then we know that the solutions are negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula, but it's not. In this situation, we have an x cubed term, so we're not able to do that. And the best strategy here is just to look for roots that are simple. So if you just test 0, f of 0 is going to be 1, so that's not correct. If you test 1, then you get 1 plus 5 minus 7, so negative 1 plus 1, which is 0. So we know that x minus 1 equals 0 is a root, or x equals 1. Okay, and that means that we can factor this like some polynomial p of x times x minus 1, right? And then we're trying to find p of x now so that we can analyze it to see if it has any real roots. It's going to look something like ax squared plus bx plus c equals 0, because we have a third degree polynomial, and then we're dividing off a first degree factor of that polynomial. So our degree is going to go down by 1. And the degree just means the exponent of the term with the highest exponent. So in this case, 3 is the highest exponent here, so the degree is 3. But for a quadratic like up here, then the degree is 2, because we have that x squared term. Anyway, this would have roots x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice that the only way that this can have real roots is if b squared minus 4ac is greater than or equal to 0. Because if it's less than 0, then this is going to be negative. And so this expression right here is going to be the square root of a negative number, which would give us an imaginary answer, and thus the whole thing would not be a real number. Anyway, so now we have to divide x cubed plus 5x squared minus 7x plus 1 by x minus 1, which actually isn't that difficult because it's a very simple algorithm. So you look at the highest term here and the highest term here, and then you think, what would I need to multiply this by to get that? And the answer here is x squared, because that'll give you the x cubed term that you need. So we would write above that x squared, and then this would be x cubed minus, and then we have the minus 1, so it's minus x squared. And then we find the difference here. This would be 6x squared. And then we'd bring down this minus 7x, so 6x squared minus 7x. And then the factor we need to multiply there is 6x, so we would add 6x up top. And so this would become 6x squared minus 6x we'd take this difference to get negative x plus 1, and then that factor is going to be negative 1, and then negative x plus 1 that has no remainder. So that also confirms that 1 is a root, because if 1 was not a root, then we wouldn't divide cleanly into this polynomial right here. Now you could also check. You could also say x squared plus 6x minus 1. If for some reason you weren't certain that it was the other polynomial, then you could multiply like this to see if you get this expression, to see if you get that equation. You would get x cubed plus 6x squared minus x squared minus 6x plus 1 equals 0, which would be x cubed, combining like terms, x cubed plus 5x squared minus 7x plus 1 equals 0, which is indeed this right here. So that just confirms that that's the polynomial that we're looking for. Let's just remember the fact that if the discriminant is greater than or equal, to 0, then we have real roots, and yeah. So b squared minus 4ac. If we look here, b is going to be 6, and a is going to be 1, and c is going to be negative 1. So we have 6 squared minus 4 times 1 times negative 1, which is 40, which is positive. And if it was equal to 0, then we would actually get one more root. If it was 0, then we would get one more root, and then we'd be at 2. And if it was negative, then we would have 0 more roots. But since it's positive, we're going to get 2 more roots. So these are both incorrect, and the answer is D. Question 2. A weighted die, when rolled, will read 1 twice as often as it will read each of 3, 4, 5, or 6. And will read 2 3 times as often. 3, 4, 5, and 6 will occur equally often. If I roll 2 such die, what is the probability that the top face sums to 7? Okay, so since we're looking for the sum of rolls, one thing you may have heard of before is something called generating functions, which is how I would do this problem. And a generating function is something that models a probability or combinatorics situation wherein you're assigning weights to different values to determine sums of those values. And this right here, we have weighted die, and we're determining their sum, right? And we're concerned about the sum, right? When the sum is 7. And so what this means is that if we consider the polynomial 1 has weight 2, so 2x, and then 2 has weight 3, so 3x squared plus 3, 4, 5, and 6 are all equally likely, plus x cubed plus x to the 4th plus x to the 5th plus x to the 6th. So this polynomial, basically what it means is, so this polynomial is just a written down way to say that rolling a 1 has a weight of 2, rolling a 2 has a weight of 3, rolling a 3, 4, 5, and 6 will have a weight of 1. And so if we roll twice, then we would say we're squaring this. We're squaring this polynomial right here. Okay. And we're gonna be, and when we square it, we're gonna get some new polynomial. Okay? And that polynomial models the weight of each possible sum of any roles, of any two roles. So if we want to find the weight of those summing to 7, then we would be able to find it. But notice that we're not looking for the weight that it sums to 7. We're looking for the probability. And that means dividing it by the weight of everything in that polynomial. So that's going to be the coefficient of every term. Okay. Well, let's find the coefficient on the x to the 7th term, because that'll give us the weight. That is going to be 12. And that is going to be 12. Now we've got our weight, right? I said before that we need the total sum of all the weights. So we'll take the ratio between the weight on the x to the 7th term over the sum of all the weights. But if you think about the sum of all the weights, if it's a polynomial and we're trying to sum all the coefficients, then that's the same thing as just plugging in 1 to the polynomial, right? So if you plug in 1 to this and then square it, then you'll get the sum of all the weights. So let's plug in 1. 2 plus 3 plus 1 plus 1 plus 1 plus 1. It's 9. And 9 squared equals 81. So our answer is 12 divided by 81, which is not simplified because these share a factor of 3. So we would divide off that factor of 3 to get 4/27ths, which is our answer. That's a pretty sophisticated technique, but it's generally pretty useful. So what I would do is I would research generating functions a little bit more. I don't know if there's an Alchemist topic about generating functions or not, but generating functions for probability and combinatorics are extremely useful in situations like this because they just organize stuff. You're not really doing anything too fancy, you're just organizing things with different terms of x. Sine of 2x equals 1 over root 3. What is sine to the... If sine of 2x equals 1 over root 3, what is sine to the 4th of x plus cosine to the 4th of x? Okay, well, I have a suspicion that this is going to involve the Pythagorean identity, and hopefully if you know a little bit of trigonometry, you'll know that sine squared of x plus cosine squared of x equals 1. If you haven't heard of that identity and you've never taken a trigonometry class, then it's worth studying. It's worth just knowing this fact, because just with this fact, you can go a long way. But we also need another bit of trigonometry, which is the double angle identity. So we're given that sine of 2x equals 1 over root 3. Sine of 2x is also equal to 2 times sine of x times cosine of x. So we're just going to keep it in that form. Okay, so let's return over here, and let's square both sides of this, right? So if we square both sides, it's still going to be equal to 1, but on the left-hand side, we're going to have sine to the 4th of x plus 2 sine squared of x cosine squared of x plus cosine to the 4th of x. Okay, so now what this means is that sine to the 4th of x plus cosine to the 4th of x equals 1 minus 2 sine squared of x cosine squared of x. Okay. So we have 2 times sine of x times cosine of x, but we want 2 times sine squared of x times cosine squared of x. So we know if we square this whole expression, we're going to get 4s squared c squared, where s and c are abbreviations for sine and cosine respectively, and that's going to be equal to 1/3. So then 1/6 would be equal to 2 times s squared c squared. So our value is going to be 1 minus 1/6, which is 5/6. If we reflect the graph of the equation y equals x squared plus 2x across the line x equals 5, what is the equation of the new graph? Okay, so let's graph this. X squared plus 2x, that's going to have roots at 2, because it's like this, factoring out an x, at 2 and at negative, it's going to have roots at 0 and negative 2. So it looks like this, because that first term is positive, so we know we're opening up. And then we're reflecting about x equals 5. Okay, that's all good. And we want to know what the new graph will be. And notice something about these answer choices. Notice something about these answer choices. They've all got different last terms, except for A and D, which both have 80, right? We might use that, but we don't know yet. We just know that they all have different last terms. And what is the last term in a quadratic? It's the product of the roots, right? If you don't know Vieta's formulas, then you can also write a quadratic with coefficient 1 like this, where R1 and R2 are its roots. So that means that the second coefficient is going to be the negative of the sum of the roots, and then the third coefficient is going to be the product of those roots, right? And that's always true for a quadratic. And that comes from writing the polynomial like this, x minus r1 times x minus r2, assuming that you know the roots, and then expanding it. So this is x squared minus r1 plus r2 x plus r1 r2, which is useful and indeed is also correct. So if we come over here and we think about reflecting about this line, x equals 5. So these are all the values when x is equal to 5, right? Well, if we're reflecting, then the distance has to remain the same, right? But we're just going to be the opposite direction. So the distance from 0 to 5 is 5, but we want to go the other way. So we would, instead of subtracting 5 from 5, we'd be adding 5 to it. So then we would get a root right here at x equals 10. And then same logic over here. This is 7 away. So we're going to go 7 away in the other direction to get to 5 plus 7, which is 12. So our new equation is going to be over here. And this is not a very accurate diagram. I'm sorry about that. But just realize that the distances are the same. We're just reflecting it. So our new equation is x minus 10 times x minus 12. Okay? If we expand that, then we're going to get x squared minus 22x plus 120. That works, but also if you remember the product of the roots, then you don't need to expand it, and you can just realize that the product of the roots has to be 120, and so the answer is E, but this also matches. You can also, you can't check the sum of the roots because negative 22 appears twice. You could, but that would just narrow it down between the two. So the answer here is E. Okay, question 5. This is an interesting question. There are multiple ways to do it. The way that a lot of people did this question was they labeled all the sides. So ABCD is a square of side length 2. So ABCD is a square of side length 2. So we're going to label those sides. And all of these little segments are perpendicular all these edges are perpendicular, and AE equals 5, BF equals 2, and CG equals 3. What is the volume of this solid? So you might have the idea to take the average of those 4 edges, right? Whatever this other edge is, and average it with all the others to multiply it with the base to multiply it with the area of the base square to get the volume, and that works. But let's just justify it a little bit more formally. So if we're over here and we cut this off, then is the area of this bit equal to the missing area? How can we know for sure? Well, let's just do some reasoning. So if we wanted to match up sides, then we would match up that side with that, and then that side with that, which my diagram isn't super duper accurate, but reasonably those should match. This is guaranteed to match with that, and then whatever this is would go right there. But yeah, we wouldn't be able to just transpose this solid necessarily. We might have to like flip it or something, but nevertheless, this is a valid way of solving it, is finding the average of these edges, but we don't have the 4th edge. So one way you could think about it is that this distance right here is the same as this distance, and when you go here to here along this line, then you're increasing by 1, right? And then, so if you were going along this line, which should be parallel to that one, then shouldn't it be the same increase? Yes, you should also increase by 1 to get DH equals 6. And so now you can average all of these, which would be 6 plus 5 plus 3 plus 2 divided by 4. But then you would multiply by 4 because that's the area of this square right here. So the answer would just be 6 plus 5 plus 3 plus 2, which is 16. But if you wanted to avoid that, then another very quick way you could do this, which was not my idea when originally doing this question, but it was a super clever solution, would be this. So you duplicate the volume, right? You make a second one, and then you rotate it and click it in so that it fits nicely with the other. And so the idea here is that you don't need to find HD. You already know that GC should have the same length as this segment over here, and you already know that this segment is of length 5, so this should be 5 and 8. And so if you just divide the if you just divide the volume of this rectangular prism by 2, then you get the volume of one of these blocks, which is what we're looking for. So that would be 4 times 8 divided by 2, which is also 16, which is pretty clever. In the next video, I'll be doing questions 6 through 10. So yeah, hopefully you learned something new, and I hope that you take away more than just what the answers to these questions are. So yeah.